What word do you see in the word concurrent? Con means what? With, together. Current means what? Like happening, right? So they're going to intersect at one point. That's what we are talking about, concurrent. And there are 4 types. First one is incenter. Incenter, write it down. You need to write these 4 things down for incenter. Incenter, you're going to construct angle bisectors. Okay, so you're going to draw an angle bisector here from angle A and B. And if I just do it roughly, guys, how do you construct an angle bisector? You draw an arc from A. Don't do it yet. Don't do it yet. I'm going to just briefly go over it. And from these 2 points, you draw an arc in the same length. And this is an angle bisector. Let's say here's another angle bisector and another angle bisector you will construct. Wherever they concurrent, when they intersect, that is called incenter. Okay? And for incenter, what you can do is you can draw an inscribed. Please write these four things down. Inscribed circle, meaning the circle will go inside the triangle. So what you're going to do is you're going to start from this point and open the compass, the radius, until it touches the side. And then when you draw a circle, it's going to touch all its sides. Okay? You see how it's touching the sides of a triangle? That means this is the radius of a circle, which is the same radius and there, here and there. So incenter is equidistant, same distance from the sides. That's a key characteristic of incenter. Okay? And I'm going to show you how to construct this. Yeah, let's construct it. So now, here's the 4 characteristics, and here I'm going to show you how to construct it again. Okay? So now take out your compass. And what do you do for angle bisector? You need to draw an arc, right? Not too big like this. Maybe if not too small, then it's not easy to find the difference. So just draw an arc. Can I use the same arc to draw the arc on the other angles? Yes. Doesn't matter. You just gotta draw an arc. What this arc do is it gives 2 points that is equidistant from the vertex. So you get these 2 points. You see it? Equidistant. 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 And now what you're going to do, it doesn't matter how wide it is. You can use the same length or open it a little wider. And then what do? You draw an axis, right? X. And you go to the other point and you draw an arc to find this X. You see how this point is equidistant from these 2 points there? So now what do? You connect this point from the vertex. This is an angle bisector. You see how it bisected an angle? So you do the same thing from the other arc. So you draw an X from there and there. And from here too, you draw an X. And then what do? Connect vertex to its intersection. Connect the vertex to its intersection. And you see how they meet at one point? It has to meet at the same point. If it doesn't, then probably you constructed the angle bisectors wrong. So that point is called incenter. What did we do? We constructed angle bisectors. And now, guys, watch this carefully. Once you have the center, you go to the center, and now you open your compass and make the radius how wide until it hits the side. So before you start drawing it, go ahead and check the other side too. You see, it should touch the side. You see how it touches? It might not be perfect, but it should look like this. You see, from the incenter, when you draw a circle inside, make sure they're all touching. That shows me what? This radius from here to here must be equal to this radius, which is equal to this radius, meaning this point is equidistant from all three sides. So they can give you a question like this on the test. They're not going to even mention about incenter, not even mention about angle bisector or inscribed circle, but they might say, here is street, first street, here is the Venice Drive, here is, only, and we want to build a club which will be equidistant from all three roads. Where should we build the clubhouse? Here, right? It should be equidistant from all three sides. Then you do what? Construct angle bisector to find the incenter, and you can draw the inscribed circle. Okay? So these four go together and just memorize.